Okay, so today we're going to take a look at some of the algorithms that we need to know about sorting and searching data. Okay, so let's have a little look and let's talk through these slides together. So let's start off first of all with the two searches you need to know. There's the linear search and the binary search, and then we'll come on to the sorts a little later on. So as you can see with the binary search, what happens is we're looking for a specific value in what has to be an ordered list. So here we're looking for the number 45. And what we do is we start off by counting the number of items in the list. Here there are 10. Starting with that middle value there, or the median value, and deciding if it's higher or lower than the number in this case that we're looking for, or if it was alphabetical, whether the letter comes before or after it. Now we know that obviously 16 is lower than 45, so what will happen is we'll get rid of 16 and all the numbers that come before it. So that's why this only works with an ordered list. We're now left with a much shorter list to check on our second search. This time we do exactly the same thing again. We'll look for that middle value. It's 23, that's lower than 45, so we get rid of that half of the list. And that then leaves us with the next one in the list, which is 45. So we found it on that third search there. Okay, and straight away we've got that number. Now if you just go back a few steps and just think what that would have looked like if you'd done a linear search, we'd have had to have done multiple checks and far more than you just saw happen then to get to the number 45. And if that was an unordered list, the 45 could have been there. But with a binary search where the numbers are ordered, we can get rid of half of the list each time, meaning that we can very quickly get to the information that we're looking for. Okay, so the linear search, here we're going to look for the number 109. So you can see it's 1, 2, 3, 4, 5, 6, 7. It's the 8th one in that list. Now with linear searches, we simply take each value in a list one at a time and compare it to the search criteria, and this is repeated until we find the number that we're looking for, and it can be very slow with large data sets. So we start off with the 65, we know it's not that, we keep moving along that number line, and it takes us 8 searches to find it rather than the 3 that it did with the binary search. And we'll just skip over those little bits there. Okay, so now we're on to the searches. They are the searches. So we've got the linear search and the binary search. Difference between the two: with the binary search, the list needs to be in order. It doesn't work if it isn't. With the linear search, it doesn't need to be in order. The length of the search: the worst case scenario is that you have to check half the values in a binary search. The worst case scenario with linear is that you have to check them all because what you're looking for is the last one in the list. Obviously that binary search there, the algorithm that you write is a bit more complex than the linear one, but the benefits of using this search algorithm are clear. In the two examples you saw, in the binary search we needed 3 runs, with the linear search we needed 8. Now then, let's have a look at some sorts. So the 3 we need to know about are the bubble, the merge and the insertion sort. The bubble sort takes the first 2 values in a list, compares them with each other, and then if they need to be switched around, it switches them around. It then looks at the next 2, the 3 and the 6, and it switches them around. It then looks at the next 2, the 6 and the 1. It compares them and it switches them around. So this bubble sort is doing this. It goes through the list 2 numbers at a time, just checking to see whether or not those 2 numbers are in the right order. And this process is repeated until the values are listed in ascending order. So the 2 and the 8 will switch, and then the 8 and the 4 will switch. On the next run through you'll see that the 5 and the 3 are going to switch. And then let's just let this happen. We know that that 8 is in its right place. 5 and the 3 are going to switch around now. There we go. Then the 5 and the 1 will switch, and so on and so on. And it'll keep running through this series of numbers until they're in the correct order. So we'll just skip that on a little bit. The insertion sort, and this time each item is in an unordered list, is examined in turn and compared to the previous item in the list. Higher values than those before them move across to the right, and the lower ones there move down to the left. And this process is repeated until the numbers are in the correct order. So you can see here, rather than checking the 1 and the 6, with the insertion sort, we're going to take that 1 and we're going to insert it exactly where it belongs by comparing it to the numbers we've already checked. The 8 is going to stay exactly where it is because it's already in the right place. The 7, well, we know we've got an 8 and the one before that is a 6, so we know we're going to slot it in there. The 2, we pick it up, we're going to check it against the 8, it's smaller. The 7, it's smaller. The 6, it's smaller. The 5, it's smaller. The 3, it's smaller, and we'll see that it pops in right here just before the 1. And then we'll do the same with the 4. So that's the insertion sort. And we'll see that one just move down the list now and slots into its correct place, and we end up with our numbers in ascending order. And then our third sort, if we just skip on, is the merge sort. So here what we do is we split all of those numbers up into their individual elements, as you can see happening here, and we end up with 8 individual numbers. The items are then merged back together in the correct order. So the 5 and the 6 go in the right order for them. The 1 and the 3, we put those in the right order. The 7 and the 8, we put those guys in the right order. And the 2 and the 4. That's the first run through. Now what we're going to do is we're going to do the same process again, this time looking at 2 lots of 2. So we've got the 1 and the 3, they go there in the right place, and the 5 and the 6. On the other side there, you can see the 7 and the 2, they'll do a little switch. Sorry, we'll bring the 4 down as well. The 7 goes there, and the 8 goes next to the 7. And then we do the same process again on the third run through. Just taking the number that comes next from each of those 2 separate lists that we had after the second run through. And there you have it. That's the merge sort. So we started off with one list, we split it up into all of its separate components, and then started to check those numbers until they were merged back together in the correct order. So there you have it. 2 search algorithms you need to be aware of. The linear search, which simply takes each value in the list one at a time and compares it with the value required. It can be quite slow, as particularly if what you're looking for appears late in the list. We've got the binary search, which only works if that list is ordered in some way, and it works with letters as well as numbers, because it could be alphabetical order or numerical order. Looks at the middle of the values in the data set and decides whether what you're looking for is above or below it, and gets rid of the half of the list that it doesn't need. That's particularly good if you've got a large data set, because each time you do the search you're getting rid of half of it. Then we looked at the sorting algorithms. We had the bubble sort, which takes the first 2 values in a list, compares them with each other, and the larger is placed after the lower. That gets repeated then along the list until you have everything being in the correct order. We've got the insertion sort, where each item in an unordered list is examined in turn and compared with the previous one. And this time, instead of doing it 2 at a time, it picks up the number as you saw in the example, and then it just inserts it into the right place in the list. And you've got the merge sort, where that list was taken, the list of 8 was taken, split into ones, and then we started to bring them together in pairs, checking them each time until we had the numbers back in the correct order. And that's it.